Good morning, class. Yesterday we have started our new topic, that was projectile motion, and I give you a brief about the projectile motion. What are the conditions that has to be taken into account, and what are the assumptions we take when we solve problem regarding the projectile motion. At the end of the video, I explained that there are three types of projectile motion possible. First was oblique, second was horizontal, and third is inclined. Out of which only oblique and the horizontal projectile motion is in your syllabus. So today we will start our oblique projectile motion and see what is the standard equation or generalized equation which shows the oblique projectile motion. Okay. Path of projectile. Consider a XY plane and you have project a body with initial velocity u at an angle theta with the horizontal. Now as the body moves, we can see that it moves into the two axes, x-axis and the y-axis. So it must have two velocity component also. First ux, that is the horizontal velocity component, and uy, that is the vertical velocity component. Alright, so horizontal velocity component ux, this will be u cos theta, and the vertical velocity component uy, that will be u sin theta. If any student have a problem that how this comes ux equals to u cos theta and equals to uy sin theta, so let's quickly see here how they come. Suppose this is u, then this is theta, we have to find this distance. So just check what is the relation between in this triangle to this arm and this arm. This is the relation of cos theta. Cos theta is base upon hypotenuse, right? So from here we get ux equals to u cos theta and uy equals to u sin theta. These are the resolved component of velocity into the horizontal and vertical form. Now, always remember one thing, that if body covers distance in vertical direction and in horizontal direction, then the distance covered in any direction is due to the velocity component of that direction. In simple words, suppose I am covering this x distance, so I will take the velocity component of x direction. I will not consider the y component. If I am going upwards, that means I am covering distance in y direction, so I will take the vertical component velocity, not the horizontal. So let's say after time t, the horizontal distance covered by the projectile horizontal distance covered by projectile So after time t, the horizontal distance covered by the projectile will be x equals to, as I said, x distance covered will be due to the horizontal component of velocity. So we will take ux here into t. Alright, so from here if you can find the value of t, t will be x upon ux, and what was the value of ux? That was u cos theta. So x upon u cos theta. Let's say this is equation number 1. Now in this time, what will be the vertical distance covered by the projectile? So in this time, vertical distance covered by projectile. Okay, what was the equation? Equation was h equals to ut minus half gt square aut. Alright, so here h will be taken as y equals to ux or uy? Uy, because we are considering now the vertical part. So uyt minus half gt square. Now you know the value of uy, that was u sin theta, and you know the value of t, which is x upon cos theta. So this expression will become, put the values, this is u sin theta into x upon u cos theta minus half gt square, which is x square upon u square cos square theta, right? So u will be cancelled, and sine upon cos is nothing but tan. So equation will become y equals to x tan theta minus x square into g upon 2u square cos square theta. So this is the equation of motion or the path of the oblique projectile motion. Alright. So this is the equation of motion or equation of the path, equation of the path of the projectile motion. So when you compare this equation with the standard equation of parabola, the standard equation of parabola is y equals to ax minus bx square, where a and b are constants, and you can see here tan theta, g, these all are the constant terms. This equation is exactly same as the equation of path of the oblique projectile. It means, it shows that path of projectile, it is very very important statement, path of projectile is parabolic. Sometime question comes that prove that the path of projectile is parabolic, then you have to prove this equation. Alright. So parabola is a basically kind of structure, like we have circle, straight line, ellipse. So similarly we have a parabola like this. This path is known as parabolic. This is not the circular, right? This is the parabolic. It's a bit flat than the circle. Okay. Now we will consider some more important terms related to the oblique projectile, like that what will be the maximum height this attained by the projectile, what would be the time period taken by the projectile to reach at this point. So let's consider these. So let's start with time of flight. Now what is time of flight? Time of flight will be the total time taken by the projectile from the instant of projection and when this projectile land at some distance, right? So take a point, let's say P here at the highest point, right? Now consider at the highest point, let between these points velocity component will be like this. There will be some velocity component of ux and some of will be, it will, you can say vx and vy. I told you that yesterday that the horizontal component velocity does not change throughout the motion. So vx will be equals to ux, but this will change. What will happen at the highest point? At the highest point there will be only the horizontal component ux and the vertical component vy will become 0, right? Because you can see here at this point the projectile is moving in a straight line in the horizontal plane, right, at the highest point. So time taken by the projectile to reach the highest point, what will be? So we can see that at highest point the Vy is 0, right? What is the equation? Equation is V equals to U minus GT, right? So we can take it as Vy equals to Uy minus GT. So from here GT will be, okay, what is the value of Vy here? It is 0. So Uy minus GT is equals to 0, right? Or P equals to Uy upon G. This is the time taken by the projectile to reach at the highest point. Excuse me. You know the value of Uy? Uy is U sine theta. So this small t will become what? This will be U sine theta upon G. Again, this is the time taken by the projectile to reach at the highest point. Now what will be total time of flight? When the air resistance is neglected, then the time taken by the body to reach at a height will be equal to time taken by body to fall from that height. Suppose I throw this chalk and it reaches at the highest point in 1 second. So this chalk will return to my hand after 1 second. So total time of flight will be 2, right? So the total time of flight T will be twice of time taken by the projectile to reach at the highest point. So from here you can find the value of T, which is 2 Uy upon G, or 2 U sine theta upon G. So this is the total time taken by the projectile to reach at this point. Okay. Now let us find out the maximum height attained by the projectile. This. Okay. So let's see how we can calculate this, the maximum height attained by the projectile. So to find these, we'll use the equation of motion. There's no problem in it. Okay, second is maximum height. Height attained by the projectile. Attained by the projectile. Right. Now again, we have to find this height. That means vertical distance. And I told you to find the vertical distance, we take vertical velocity component. So according to second equation, what is the value of h? H will be taken as ut minus half gt square. First we have this and second we have formula v square equals to u square minus 2gh, right? So I think this formula will be beneficial to find out, because in this we want time. So let's use the third equation. Third equation is v square equals to u square minus 2gh, right? V, what is the velocity at the highest point? That is 0. So it is, we have vy square equals to uy square minus 2gh. Vy is 0. Again I telling you why, because at this point consider that the particle moving in the horizontal plane, it is not attaining any height, or it is not dropping down, right? It is moving like this, and that is why at the highest point Vy becomes 0. So put it here, this will become uy square minus 2gh is equals to 0, or 2gh equals to uy square, right? So this becomes h equals to uy square upon 2g. What is uy? Uy is the vertical velocity component, whose value is u sine theta. So put it here. So h will become u square sine square theta upon 2g. This is the value of maximum height attained by the projectile. The last term related to this projectile is range of projectile. Here the range means the maximum, or we can say the total horizontal distance covered by the projectile at the end of the time of flight. Like this is the projectile motion, okay? Project with the velocity u at an angle theta. This distance is regarded as r, the range of projectile. So here we are calculating the horizontal distance, right? Horizontal range. So horizontal range will be equals to horizontal velocity multiply by time of flight. Obviously total time of flight will be this. So r will be equals to ux into time of flight was t, that was uy 2uy upon g. So r can be written as ux into 2uy upon g. So this is our first formula. Take 2 at this side, it will be 2ux uy upon g. So this is the first formula for the range of the projectile. Now if you put the value of ux and uy, then you can take a screenshot. So r can be equals to twice of ux is u cos theta and uy is u sine theta divided by g. Alright. So this can be written as r equals to u square into 2 cos theta into sine theta upon g, right? Now if you remember, this is the formula we use in trigonometry. You won't know that sine 2a is 2 sine a into cos a, right? So 2 sine theta into cos theta, that means the formula of 2 sine a. So the formula will become r equals to u square sine 2 theta upon g. So this is one more formula of range of projectile motion. Okay. So these all three formulas are very important. You'll find numerical directly based on these formulas. So please note them and memorize this formula and try to solve more and more question on these we can say formulas. I think we are left with some numerical in this chapter and some concept on the projectile. Otherwise, we have completed this chapter. So we'll start the numerical in the next video. Till then, class. Thank you so much.